these two things are not magnets. Neither one of them will stick to a magnetic force at all, but yet both of them have electrically charged particles in them. They're just not reacting to each other now. But yet, if we build up static electricity on our hair or on our shirt, which is a lot of fun to play with actually. Who can keep theirs on the table?
So we are talking about electricity, and what that is. Electricity is a charge of particles such as electrons and protons, and it's either an accumulation of charge such as static or dynamically through a current, which I'm going to show you here. What we've done is created a current. We have the batteries, which are supplying the power, and there is a wire attached to each end which is connected to the power source. So these are flowing with power. However, they're not going to operate this fan unless it's touching. So we can attempt to touch just one side of the wires together, as you can see here. And once we do that, the fan still will not operate. That's because the electricity needs a continuous circuit to flow through. With the break in the chain, the electricity cannot flow and will not conduct through the wires, and the charge will not work. So I'm going to have her hold the fan for me, and I'm going to take this side and again connect them. Without them being both connected, there is no operation. However, when we complete the circuit, the electricity is allowed to flow through the circuit and conduct the particles into the operating fan and operate the motor. Once we break the circuit, it no longer continues to operate. That's how electricity functions through current.
We're going to show how a circuit works using these. They're squishy circuit clay, and they have salt in them to use as a medium. What we're also going to use for a power source is a 5-volt charger. It's plugged into an outlet. Now, what should happen is when we plug these in and then we connect the fan into it, the fan should start up. So I'm going to insert these. Gianna, if you'll insert the others. And voila, it does not work. So in case the size of the squishy circuit clay is too big, it's causing too much resistance, we're going to try smaller clay balls. Thank you, Gianna. I'm sorry, Michelle. So we try once again, inserting directly into it. And yet it still does not work. We followed the recipe that we received from another student of the EMPACTS class. We followed their recipe exactly, and it was also the same as one we found online for another university, but it just didn't work for us. So to make sure that both the charger is working and the fan, we're going to try just to connect directly to make sure that it is capable of working and the fan does come on. So this experiment failed, but we did learn something from it, and that's you do have to test other people's recipes and don't take them for face value because they may not exactly work for you.
So after the failed dough experiment, we decided to try to use a solution of high salt content water. Salt is a good conductor of electricity, and we can show that electricity can pass through the medium and still operate the motor. So what we've got here is the same mode we used before. We've got the charger, the 5-volt charger, and the fan operating. So if you want to connect those two ends right there, those together for me. Once we place the two ends separately into the salt solution, as you can see, it does operate the motors. The salt is a conductor of electricity and does operate